Max sum ascending subarray. I'm thinking we keep a tracker of the previously iterated value. We iterate through the remainder of the values, ensure that A, we're ascending, and B, adding. And then we'll also keep track of the max as we iterate throughout the entire array. So I'll have int max equals 0, int prev equals nums 0, and then int counter int sum equals 0. And then we're going to iterate from 1 to nums.length if the previous value is less than the current value, then this has to be num0 as well. Sum is going to plus equal nums0 or nums I. Otherwise, sum is going to equal nums I, and then previous is going to equal nums I, and then max is going to equal math.max between max and sum, and we return max. Oops. Well, I missed one thing. Oh. They're all num0. Took me less than 2 minutes to do this problem, bro. Oh my gosh. It's getting too easy. I don't want it to be this easy. I think I have finished this. Okay, so here we're going to use a hash set and then add all the numbers into it. And whenever we encounter a number that we've already added to the hash set, then we will return true. If not, then we return false. So we're going to make a set that stores integers called set. Make it a hash set. We're going to iterate through all the numbers. For every number in num, if we cannot add the number in the set, we're going to return true. Otherwise, we're going to return false. This occurs in O of n time and O of n space. So for this, what we're going to do is we're going to create a frequency array, and we're going to add every character that we encounter in string s, and then we're going to subtract every letter that we encounter in string t, And then we're going to iterate through the frequency array and make sure that all the values equal 0. If there are any values that do not equal 0, we do not have a valid anagram. If we have all values that equal 0, then we have a valid anagram. One more thing to note is that if they are different lengths, then we know that it is not a valid anagram. So if s.length does not equal t.length, we can return false. And then we'll make a frequency array with 26, with the size of 26, because there are 26 letters in the alphabet. And then we're going to iterate through s.length, and for each character in S, we're going to increment. For each character in T, we're going to increment or decrement. And the reason why we do the subtraction of both of them is because we want to take the character and subtract it by the base, which is A, because all the potential letters are all lowercase and they're English. So then we do that. Then we're going to iterate through the frequency array, and if the current frequency does not equal 0, we're going to return false, and then we're going to return true after we've processed everything. This occurs in O of n right here, and we have a space of O of 1 because 26 is a constant. So for TrueCell, what we're going to do is we are going to iterate through each value and then cache that value and its index. And when we have our cache, every time we encounter a new value, we're going to see if we've previously iterated on its complement for the target. And if that's the case, we're going to return a new array. If it's not the case, then we're going to add it to the cache and then continue processing. So yeah. So here I'm going to make a hash map that stores an integer as a value and a key. We're going to name it. What just happened? That was weird. My entire screen went black. Okay, we're gonna make a hash map that stores integers as a key and value and call it cache. It's gonna equal a new hash map. And then we're going to iterate through each value in nums. And if the map does not contain the key of the complements that we're looking for, which is target minus nums I, if the map does contain it, we're going to return a new int or array with the current index and the index from the cache of the complement. And we are also going to rename this to cache. Perfect. And then if we don't have the key, we're going to take the map or the cache and put in the current number and the current index. And then I'll just return an empty array as an exit condition. This occurs in O of n, and O of n time and O of n space. Okay, group anagram. So what we're going to do is we are going to create, we're going to iterate through all the strings, and then we're going to create a frequency array for each string, and we're going to turn that frequency array into a string that serves as a key for a hash map. And the hash map will store the frequency array based off of the current word as the key, and a list of strings that are the words that equal that key as the value. And what we're going to do is we're going to iterate through each one of these strings, calculate the frequencies, add them into the hash map, and then I'm going to convert that to a two-dimensional list with the grouped anagrams. So here I'm going to create a hash map with the key as a string and the value as a list of strings, and I'm going to call it a map. And then I'm going to iterate through all the strings in strs, and then I will make a frequency array of size 26 because there are 26 characters in the alphabet, and I'm going to iterate through each character in the current string. And I'm going to take the frequency array, take the character that I have iterated at by, subtract it by a lowercase a, and increment it once. And then I'm going to make the key by converting the frequency array to a string. If the map does not contain the key, I'm going to put the key in the map in a new array list as the value. And then I'm going to take the map and get the key and add the current string. Then we have grouped all the anagrams, but we need to convert the hash map to an output. So I'm going to return a new array list of strings, and I'm going to use map.values. Oh, it contains keys. Can I just do this? Pretty sure there's a way to convert. Oh, I guess there's no explicit. Why does that break it? That's weird. I guess it has to be implicit. Yep, that works. So this occurs in, is there a better way to, I guess I can name this groups. Yeah. So this occurs in O of n. This is O of m. And then storage is O of n. So O of n times m is the time complexity, where n equals the number of strings and m equals the average length of each string. And then O of n is the number of strings as the size. And I'm pretty sure this should be faster. Yeah, there we go. Is there a faster way to do this? Oh, sorting. Yeah. That is slower technically. Alright, top K frequent elements. Let me think about how I was going to do this. So, So I'm going to make a frequency array. I'm going to make a frequency array and then use the I'm going to count the frequency of each of the values, and then I'm going to use the frequency array. I'm going to use the frequency array's index to sort the values, and I'm going to use the value of the frequency array to determine which number it is. So what's a better way to explain that? So I'm gonna store all the frequencies of these numbers in a hash map, and then I'm gonna iterate through the entire hash map and place it into a frequency array by frequency. So the array will be size n, which is the length of m, because there can't be more than n frequency of anything in the array. And I'm going to use the frequency that we find and store in the hash map to store the value in the current index. Yeah, that's the best way I can explain it. So here I'm going to make a hash map that stores integers and there's an integer as a key and a value, and I'm going to name it freak equals new hash map, and then we're going to make an array list of integers, and we're going to make an array of those array lists. I think I'm just going to do list here, and this is going to be r equals new array list integer or array list, and it's going to be nums.length. So for each number in nums, frequency is going to put the number and frequency.get or default the number 0 plus 1. And then I'm going to take the frequency and iterate through each key and value. And for if the frequency of the array, if the value at the frequency of the array is null, I'm going to take that and make it equal to a new array list. And then I'm going to take that and add the key. And then I'm going to iterate from the end to the beginning of the array, not the frequencies. So if Ri does not equal null, then I need my output array as well, so int output equals new int k, and then I need to keep track of what index we're currently at. So if the current value or current portion of the array is not null, and then we're going to iterate through each value in that frequency. So r equals ri equals 0, j has to be less than ri dot size j plus plus. We're gonna get output index plus plus equals ri.get j. If index equals k, then we're going to return output. Otherwise, we're going to return output. And that should be it. Oh, new. There we go. So this occurs in O of n. This is O of n. No, this isn't really O of n, but this is O of n. This is yeah, this is at worst O of n. This is at worst O of n. This is at worst O of n. So this occurs in O of n. Size is also O of n. Okay, so here we're going to use the string builder. Actually, let's just go one by one. For encode, I'm going to use the string builder to append the length of the word, a delimiter, and the word itself. And I'm going to do that for each word into the string builder. And then I will return that string. For decode, I'm going to deconstruct that pattern. So I'm going to use a two-pointer method to capture the length of the next string, and then I'm going to add from where my position is to that length to capture the word, and then continue doing that. So here I'm going to make a string builder called string builder. It's going to be equal new string builder. And for each string in string, I'm going to take the string builder and append the current length of the string, append a pound sign as the delimiter, and append the word itself. And then I'm going to return the string builder dot toString. And then to decode, I'm going to make a list of strings called the output. And then I'm going to keep track of 2 pointers. And while I is less than 0, actually don't think we need this. Actually, we might need it. While I is less than 0, I'm going to iterate while string.char at I does not equal the pound sign. And then I'm going to be able to capture the length. Length will equal, this might be j. Length will equal string.substring ij. And then I'm going to integer.parseInt that value. And then j will now be on the pound sign. So we need to iterate j, or increment j once, and then take the output and add string.substring j and j plus length. And then j is going to plus equal length. I might not even need I. Return, and then we return the output. I will need int I. Int I equals 0. Alright, something's clearly wrong. I believe it's in the decode. Oh wait, less than 0. String.length. There we go. Okay, so encode happens in O of n time, where n is the length or the number of strings, and also O of n space, or n times m space, where n is the number of strings and m is the average length of the strings. And then decode occurs in O of n, where n is the number of O of n, where n is the length of the string that's passed to the decode. Okay, so we're going to create an array, and we're going to calculate the product of everything to the right of each index in the array. So here, we're going to have 0. Here, we're going to have 1. Here, we're going to have 2. And here, we're going to have 6. And then we're going to do the same for the left-hand side. So here, we're going to have 0. Here, we're going to have 4. Here, we're going to have 12. And then here, we will have 24. So when you take those two values and then multiply them by each other, so here I'm going to take 1 times 12 and I'm going to equal 12. Here I'm going to take 2 times 4 and I'll equal 8. And then here I'm going to take 0, so we don't count that, times 6, which is effectively 6 times 1. Here, 24 times 1, which is 24. So I'm just going to do that. So we're going to create an output array and make it the length of nums. We're going to iterate through nums. Let me do this. Int n equals nums.length. Int output equals new int n. For int I equals 1, I has to be less than n, I plus plus. Output I equals output I minus 1 times nums I minus 1. I'm also going to fill the output array with 1s because anything times 0 is 0, so we want to make sure that the values are at least themselves. I'm going to create a rolling product variable and then iterate through the array backwards. And I'm going to say output I is going to times equal output I minus 1, or wait. Oh, times equals rolling product. I'm going to take the rolling product and times equals it to the current value. And then I'll return the output. And that didn't work. I don't think that was... What? I wonder what happens if I comment this out. Oh, rolling product has to be 1. Whoops. There we go. Time complexity is O of n, space complexity is O of n, where n is the number of nums. Valid Sudoku, so this is just a simple Sudoku validation. Basically, I'm going to iterate through all of the columns and all of the rows, and I'm going to create hash sets to be able to determine whether or not I have encountered a duplicate value in the respective row or column. And then I'm going to iterate each subgrid, each 3x3 box. And if I'm going to use the same method by using a hash set to determine whether there are any duplicate values in that subgrid. And then if all tests pass, I will return true. If any of them fail, I'll return false. Oh my gosh. So I'm going to iterate through the rows. I'm going to iterate through the columns. And I'm going to create a hash set called setX, which represents the values in the column. And then I'm going to make another one called setY, which represents the values in the row. I'm going to create a variable called curX, which equals the current row value. And then I'm going to make a variable called curY, which equals the current column value. If curX does not equal period, and setX can add curX, or yeah, so if curX does not equal period and setX cannot add the curX, then I'm going to return false. And I'm going to do the same thing with Y. Set y.add cur y, return false. And then I'm going to iterate through each subgrid, and I'm going to plus equals 3 every time because we want to navigate each subgrid. And then into row is going to equal I, row is going to be less than less than I plus 3, row is going to be plus plus. And I'm going to do the same thing with the column. Column equals j, column cannot be less than j plus 3, column plus plus. And then here I'm going to make a set of characters called subgrid. And I'm going to say if our char cur equals board row call, if cur does not equal a period and subgrid cannot add cur, we're going to return false. Otherwise, we will return true. That was O of n times n, where n is the number of rows and everything that it calls, which is 9 by 9. Okay, so what we're going to do here is we're going to take each number, add it to a hash set, and then I'm going to iterate through each value and say, okay, does this value -1 exist in the hash set? If it does, then we know we are not at the bottom of its respective consecutive sequence. If it doesn't exist, then we know we're at the bottom of its respective consecutive sequence. So the answer here will be 1, 2, 3, 4. But how do we know that all these exist? Well, what we can do is we can take 4 and say, okay, does 3 exist? Yes, it does. That's fine. We'll take 3. Does 2 exist? Yes, it's fine. Or it's right here. Does 1 exist? Yes, it's right here. Does 0 exist? No, it doesn't exist anywhere. So we know that 1 will be the bottom of this respective subsequence. So what we do is we just say, okay, 1. What's the next value that we were expecting? 2. Does 2 exist in the hash set? It does. Does 3 exist in the hash set? It does. Does 4 exist in the hash set? It does. Does 5 exist in the hash set? No. And through that, we'll keep track of a counter variable as we iterate like so. And then we will just keep a max variable, or a variable that tracks the max length. And we will iterate as much as we can. But the key is to be able to identify the beginning of each sequence, which will allow us to maintain linear time. So I'm going to make a hash set that stores integers called set. I'm going to iterate through all the numbers. I'm going to add each number in the set. And then I'm going to iterate through each value again. And I'm going to say if set contains, does not contains nums I minus 1, then we will start processing. So I'll have int max equals 0, int counter equals 0. So while set contains nums, or int cur equals nums I. Well, set contains cur. I'm going to take counter plus plus, cur plus plus, and then max is going to equal math.max between max and counter. And then I'm going to return max. Uh-oh. Oh, wait. And then counter is going to equal 0. Perfect. Now, this may look like it occurs in O of n squared time, but it does not. This while condition actually guarantees... What the? What? Wait. That shouldn't be happening. Am I doing something wrong? What am I doing wrong? I'm almost certain. Does that really change everything? I doubt this changes anything. Do they add a test case? This is the copied answer. Wow. They added a test case. 76 test cases. Yeah, 79. Whoa, what the? That's crazy. They added more test cases. There's no way this works. It's the same thing. How does that work? There's no way. Wait, if I do this. Yeah, that's whatever. There's no way. Why am I TLE? This is the same thing. Oh my gosh. There's no way. This changes everything? Oh. How does that TLE? That's crazy. I don't know if I agree with that. I really don't know if I agree with that. Alright, I gotta do a few things on my laptop now. But I'm tired. We're done here.